Right now we are building, you can see the pier number 9. That is the tallest pier, about 43.5 meters high.
Imagine building a railway that has to support thousands of tons of weight, cross burning deserts, pass through open savanna and dense wildlife zones, all without disrupting wildlife. Sounds impossible? But that's exactly what China has done by building a modern railway stretching nearly 500 kilometers from Mombasa to Nairobi. This track cuts through deserts, valleys, and vast wildlife regions, all while being supported by massive concrete pillars that allow animals to move freely beneath it. And that's not even the craziest part, because China completed this entire project in a record time of 3 years. So the question is, how did they do it? And what did it really cost? This is the story of how China built one of Africa's most ambitious railways and changed a nation forever. A broken system. Kenya needed a better transport system because people could not move goods fast between cities. The railway was built between Mombasa and Nairobi, a distance of nearly 500 kilometers. This railway line came from British rule more than 100 years ago, and no one has upgraded it after that time. Trains moved very slowly and could not carry enough goods for a growing country. A journey that should have taken only a few hours often took more than 24 hours to finish. Mombasa sits on the coast and works as one of the busiest ports in Africa. Ships arrive every day with goods for Kenya and nearby countries like Uganda, Rwanda, and South Sudan. These goods must travel inland, but the transport system makes this process very slow and expensive. Trucks filled the main roads and caused heavy traffic. Many trucks broke down because of the heat and long distances. Drivers waited for hours, and sometimes for days, before they reached Nairobi. This delay increased the cost of everything. Businesses paid more money to move goods from the port to the city. In fact, companies in Kenya paid more to move one container from Mombasa to Nairobi than companies in Europe paid to move goods across entire countries. This situation created serious problems for the economy. Prices increased for basic products, and people had to pay more for daily needs. Farmers faced major losses because they could not send fresh produce to markets on time. Factories could not receive raw materials quickly, so production slowed down. Hospitals and clinics waited longer for medical supplies, which affected patient care. The entire system slowed down growth across the country. Kenya wanted to compete in global markets, but the weak transport network held it back. Roads alone could not solve the problem, and the old railway continued to fail year after year. Tracks became damaged due to heat and heavy use. Bridges grew weak and unsafe. Some parts of the railway stopped working completely and were abandoned. The country needed a modern system that could move goods quickly, safely, and at a lower cost. The China entry. In 2014, Kenya faced a serious decision that would shape its future for many years. The country needed a modern railway, but building such a system required huge amounts of money, advanced machines, and skilled engineers. Kenya could not complete this project alone. At that time, China stepped forward with an offer that changed everything. China's Exim Bank offered Kenya a loan of about $3.8 billion to fund the railway project. This was not a small amount. It was one of the biggest infrastructure investments in the country's history. Along with the money, China also brought a powerful construction company called China Road and Bridge Corporation. This company agreed to handle the entire project from start to finish. It would design the railway, build it, and deliver it fully ready for use. Thousands of skilled workers arrived in Kenya. They brought modern construction methods that had already been tested in other large projects. These workers did not just build the railway, they also trained local Kenyan workers so they could learn new skills and support the project. This railway project was not just a simple deal between two countries. It was part of a much bigger plan called the Belt and Road Initiative. Through this plan, China invested in roads, railways, ports, and other projects across Asia, Africa, and many other regions. China did not do this only to help other countries. It also created long-term benefits for itself. When China built this railway, it used Chinese steel, Chinese machines, and Chinese systems. It also built strong trade relationships that could last for decades. Some people saw this as smart planning. Others saw it as a long-term economic strategy. But for Kenya, the result was clear. The country finally had a chance to build a railway that it could not build before. Before construction began, Chinese engineers started detailed planning. First, they studied the entire route between Mombasa and Nairobi. They used satellite images and aerial surveys to understand the land. They mapped every hill, valley, and river. They checked where the ground was strong and where it was weak. They also decided where they needed elevated sections to protect wildlife and avoid difficult terrain. This planning stage involved hundreds of experts working together for many months. They collected data, tested conditions, and prepared detailed designs. Every step had to be correct before construction could begin. A small mistake at this stage could cause major problems later. Once planning was finished, construction started at full speed. Supply chains delivered steel, cement, and equipment to many construction sites at the same time. The project moved like a well-organized system where every part worked together. The goal was clear, but very difficult. They had to build a modern railway across nearly 500 kilometers in less than 3 years. This timeline sounded almost impossible, but the team pushed forward with careful planning and strong coordination. But soon, they faced a challenge that no amount of planning alone could solve: taming the ground. The railway passed through long stretches of open savanna where the soil was loose and sandy. This type of ground could not support a heavy railway system. If workers placed concrete and steel directly on this surface, the structure would sink, crack, or collapse over time. Engineers needed to fix the ground before they could build anything on top of it. They began by clearing and leveling the land. Bulldozers moved across the area and removed uneven surfaces. They flattened hills and filled low areas to create a more even base. But this step only prepared the surface. It did not solve the deeper problem of weak soil. Loose sand does not hold weight properly because it contains air gaps between particles. When pressure increases, the sand shifts and loses shape. To solve this, engineers used water to change the structure of the soil. They sprayed water across the ground using long mechanical arms. When the sand absorbed the right amount of moisture, the particles started to stick together. This made the surface denser and more stable, similar to how wet flour holds its shape better than dry powder. After this, workers used a method that relied on force. Large cranes lifted heavy steel weights and dropped them onto the ground repeatedly. Each impact sent shock waves deep into the soil. These waves pushed particles closer together and removed empty spaces inside the ground. Over time, the soil became tighter and stronger. This process continued until the surface reached the required strength. Next, heavy rollers moved back and forth across the land. These machines pressed the soil further and made it even more compact. Each pass increased the density and reduced movement inside the ground. Workers repeated this process many times to ensure the soil stayed stable under pressure. After compacting the sand, workers added another layer. This layer provided additional strength and stability. They compacted this layer again using rollers and machines. Step by step, the ground changed from loose sand into a solid base that could support heavy structures. This process did not happen in one place only. Workers repeated it across hundreds of kilometers along the railway route. Each section required careful testing before moving forward. Engineers checked the strength of the ground at every stage. If they found weak areas, they repeated the process until the soil reached the required level. The weather added more difficulty to the work. Temperatures often rose above 30 degrees Celsius. Workers had to continue operations under strong heat. To maintain progress, teams worked in shifts. This continuous effort helped keep the project on schedule. By the end of this phase, the land had completely changed. What once felt soft underfoot became hard and stable like compact rock. This transformation created a strong base for the next stage of construction. With the ground ready, the project could move upward into a much larger and more visible structure. Pillars above earth. After engineers prepared the ground, workers started building the structure that would carry the railway above the land. This part changed the entire look of the project. Instead of placing tracks on the surface, they raised the railway high into the air. This design protected wildlife and allowed movement below without interruption. Workers began by building thousands of concrete pillars across the route. Each pillar stood about 15 meters tall, which is close to the height of a 5-story building. Each one weighed nearly 90 tons. Engineers placed these pillars at a distance of about 35 meters from each other. When you calculate this spacing across nearly 500 kilometers, you get thousands of pillars forming a long, elevated path stretching across Kenya. Workers built every pillar directly on site. They assembled strong steel molds and filled them with reinforced concrete. Inside each pillar, they placed steel bars to increase strength. After pouring the concrete, they allowed it to cure and harden properly before removing the molds. This process was repeated again and again across the entire route. The heat in Kenya made this work more difficult. Workers had to control the curing process carefully because high temperatures could weaken the concrete if they rushed the work. They checked alignment at every step because even a small mistake could affect the entire structure above. Once workers completed the pillars, they moved to the next step. They needed to connect these pillars to create a continuous platform for the railway. Engineers used large concrete beams called precast girders. Each girder measured around 30 meters in length and weighed close to 100 tons. Workers manufactured these girders in controlled areas near the construction site to maintain quality. To make these girders stronger, engineers used steel cables inside them. They stretched these cables tightly before pouring the concrete. This method allowed each girder to carry heavy loads without bending or cracking. Workers used a special machine called a launching gantry to place the girders. This machine moved along the top of the pillars and lifted each girder into position. It placed the beam between two pillars with high precision. The margin of error remained very small, often just a few millimeters. Even a slight misalignment could create problems later. Workers repeated this process across the entire route. They placed one girder after another and slowly built the elevated track. Day after day, the structure grew longer. Each completed section added more length to the railway. Animals continued to move freely under the structure. Even areas like Nairobi National Park remained undisturbed because the railway stayed above the ground. By the time workers finished this stage, the railway had taken a clear shape across the landscape. The structure looked like a long chain of concrete stretching across the plains. It stood strong and ready for the next phase of construction. Now the project needed a system that could carry trains safely across this massive structure. Precision in steel. After workers finished the elevated structure, they moved to the next important stage. They needed to build the railway track that would carry trains safely across the entire distance. The rail needed a flat base, a strong center, and a rounded top where train wheels would move smoothly. By the end of this process, each billet stretched into a rail as long as 100 meters. This meant one piece of steel could cover the length of a football field. Workers then cooled the rails slowly to prevent cracks or bending. They straightened each rail using special rollers and cut them into standard sizes before sending them to Kenya. This careful process ensured that every rail met strict quality standards. At the construction site, workers prepared the base for the rails. They placed concrete sleepers along the entire route. The number of sleepers required for this project was very large. Workers needed about 1,600 to 1,700 sleepers. When you multiply this by the full railway length of about 472 kilometers, the total reaches hundreds of thousands of sleepers. Each one had to be placed carefully to maintain proper alignment and spacing. The final step involved joining the rails together. Workers used a method called thermite welding. This process created extremely high heat through a chemical reaction. The heat melted the ends of two rails and fused them into a single continuous piece. Once workers repeated this process across the entire line, the railway became a smooth, unbroken track. This continuous design removed gaps and weak points. It allowed trains to move at high speed without vibration or noise from joints. The railway became strong, stable, and ready for operation. By the time workers finished this stage, the entire system stood complete, from ground to track. The railway now had the strength, precision, and design needed to handle heavy trains across long distances. This railway changed how people live, work, and travel in Kenya. It turned a slow system into a fast and reliable one. But questions remain about its future and cost. Some people see progress, while others see risk. So, what do you think about this entire mega project? Let me know your thoughts in the comments below. And if you found the video fascinating, make sure you give it a thumbs up. Also, consider subscribing to the channel because we'll be uploading more incredible stories like this one soon. Until then, see ya.